In this video, let me consider one numerical on loop analysis or mesh analysis. Find Ix and Vx for the circuit shown below using loop or mesh analysis. So this is the given circuit. So in this circuit, we need to calculate current Ix and current voltage Vx, where voltage Vx is the voltage across 1 ohm resistor. We need to calculate this using loop analysis or mesh analysis method. Here we can observe that we have 3 amp independent current source and we have voltage dependent current source, that is Vx by 4, where Vx is voltage across 1 ohm resistor. So here these two are in parallel. These two can also be represented as this. This is, I can draw the equivalent circuit of this. So here these two are parallel. I can replace it with single current source, that I can represent it like this. This is current source. The magnitude of this is Vx by 4 and this is 3 amp, that is plus 3. So it is same as this one. Now here we can observe that there are two loops. Let me assume current through this loop is I1 and let current through this loop is I2. So from this circuit we can observe that there is a current source between two loops. If there is a current source between two loops, we have to analyze the current source first, then we have to apply KVL to this entire loop. That entire loop is known as super loop. Let this current source, here we can see that I1 and I2 are in same direction. I can write I1 plus I2 is equal to Vx by 4 plus 3 is opposite direction. So I can write minus Vx by 4 plus 3. Further here we can observe that Ix is the current flowing in same loop and I1 is current in this loop. But Ix and I1 are opposite to each other. I can write I1 is equal to minus Ix. Also I can write here that Vx is equal to, that is voltage across 1 ohm resistor, that is 1 into both I1 and I2 are flowing, that is 1 into I1 plus I2, or I can write Vx equal to I1 plus I2, or I can write Vx equal to I1 is nothing but minus Ix plus I2. Let me call this as equation 1, this as equation 2, this as equation A. Now I will substitute I1 value and Vx value in equation A. That is, substitute one and 2 in equation A, so that I can write I1 is nothing but minus Ix, that is minus Ix plus I2 is equal to, we have minus Vx by 4. Vx is nothing but I2 minus Ix, that is I2 minus Ix divided by 4 plus 3. Further I will simplify this. Here I can write I2 minus Ix is equal to, here we have minus 1 by 4. Here it is 1 by 4 is 0.25 I2 minus 1 by 4, that is 0.25 Ix plus 3. Further I can simplify this as I2 minus Ix is equal to, we have minus 0.5 I2 plus 0.25 Ix minus 3. Further I can simplify this. I'll take 3 on LHS. I can write 3 is equal to, we have minus 0.25 I2 plus 0.25 Ix. I'll take this Is on this side. It will become, sorry, this is small I. This is small I. Ix. Take Ix on this side, that is plus Ix. Take I2 on this side, that is minus I2. Or I can write 3 equal to 0.25 plus 1 is 1.25. We have Ix it is minus 0.25 minus 1, that is minus 1.25 I2. Let me call it as equation number 3. This is equation number 3. So now, after analyzing the current source, we have to assume that this branch is removed from the circuit. If we remove this branch from the circuit, we'll get only one loop. This loop is known as super loop. We have to apply KVL to super loop, considering I1 and I2 separately. Now let me apply KVL to this super loop. That is, apply KVL to super loop. Therefore, I can write 50 is equal to we have 10 I1. Here we are moving in this way, but current I2 is opposite to that. It will be minus 5 I2. Then we have plus 4 ix, that is plus 4 ix, or I can write 50 is equal to, so already we know I1 is nothing but minus ix, so it is minus 10 ix minus 5 I2 plus 4 ix, or I can write 50 is equal to, this will be minus 10 ix plus 4, that is minus 6 ix minus 5 I2. So let this be equation number 4. This is equation number 4. Now we have to solve equation 3 and 4 to get the value of ix and I2. That is, solving equation 3 and 4, we get, so keep the calculator in compound mode, then keep the calculator in equation mode. So here there are two unknowns, so choose option 1. Ix is 1.25, coefficient of I2 is minus 1, so that is 1, coefficient of Ix is 1.25, coefficient of I2 is minus 1.25, and this value is 3. Similarly, so here coefficient of Ix is minus 6 equal, coefficient of I2 is minus 5, and this is 50. So press equal. So first variable is with respect to Ix, so Ix is minus 3.454. Ix is minus 3.454, and another value is I2. Press equal. The value of I2 is minus 5.854. Ix is equal to minus 3.454, and we have I2 is equal to minus 5.854 amps. So thus we found the value of Ix, which is 3 minus 3.454. And now let's calculate Vx. So already we know that Vx is nothing but minus Ix plus I2. That is, Vx equal to, we have minus Ix plus I2. Minus Ix plus I2, that is Vx equal to minus Ix. So it will be 3.454 plus I2. I2 is, we have minus 5.854. So here we have 3.454 minus 5.854. It gives minus 2.4. That is, Vx is minus 2.4 volts. Thus we calculated Vx and Ix for the given circuit. Thank you for watching.